Hello, this is my personal flight simulator. I'm trying here to reproduce the 2005 Piper Meridian single-engine pressurized turboprop that I fly in real life. In this simulator, I have used some commercial elements such as the basic flight simulator and some of the instruments. But most of the other instruments are my own creation, and I've coded about 5,000 lines of code to create this instrument panel. The out the window view is shown in three 65-inch OLED monitors. The camera is now panning from the location where the pilot's eye would be, and as you can see from this one location, it's almost a seamless 190-degree view from one wingtip to beyond the other wingtip. Instead of the typical spring-loaded yoke and rudder pedals, I am using a set of electrical motor controlled yoke and rudder pedals. One of the realism features of these electrically loaded controls is that it mimics the loads that the airplane actually imposes on the controls. For instance, with the engine stopped and the aircraft stationary on the ground, the elevator on the Meridian tends to drop by its own weight. So if you pull the elevator nose up, but then let go of the yoke, it will fall down by its own weight. As the airplane picks up airspeed, the airflow equalizes the elevator and the yoke doesn't drop forward anymore. I have tried to recreate as much as possible the panel on my 2005 Piper Meridian. Since I don't have lots of room, I had to place everything on the single touch panel display. So the actual location of each of the elements is not the same as in the real panel, but the shape and feel of the elements are the same. I have the top left switch panel with the same kind of switches as in the real Meridian. And here's the right overhead panel. The annunciator panel is as close a replica as I can of the actual annunciator panel on my airplane, and the same thing for the Meggitt engine display instruments. I also hand-coded the Magic 1500 autopilot control head, the actual wing flap indicator, left and right electrical rudder trim switch, the combined voltage and current and rudder trim position display, the shape of the landing gear lights and the gear warning, which I will demonstrate when we fly. And I've located under the primary instruments the bleed air, which on my airplane is actually in the center console, the emergency gear release, and the parking brake. I also modeled the cooling of the fuel. On the Meridian, there is a spec on minimum fuel temperature, and this temperature instrument models the heat exchange between the outside air and the fuel, so it will cool realistically as the airplane climbs to colder temperatures. Same thing for the pressurization system. I can set the pressurization to off, normal, high, and emergency. And the cabin pressure dump also works in the sense that the cabin altitude behaves very much like the real airplane, and I verified the pressurization and depressurization time constants, and they're very similar to my airplane. I also hand-coded the mid-continent standby attitude instruments, and it reflects more or less the behavior of the real instrument. The one instrument I have not been able to include in my simulator is the Garmin G500 or G600 combined primary flight display and multifunction display. Here it is on my real airplane, and yes, it does say flight level 300. My Meridian is one of the very, very few Meridians which has the RVSM supplemental type certificate. Now, why the alternative setting is 2993 versus 2992, that I cannot explain. So instead I've had to use two payware Garmin G5 electronic ADI and electronic HSI. It does not provide all the functionality of the G500, but it will have to do until someone comes up with a G500 Garmin trainer adaptation for a flight simulation. The software system that I'm using to build up the control panel takes advantage of a device called an Obster, and it allows me to rotate any of the instrument panel knobs by using a single physical knob. So for instance, if I want to change the altitude preselector on the autopilot, I first touch the autopilot altitude select knob on the autopilot, it highlights, and now if I use the smaller button, I can change the hundreds on the pre-select altitudes. The larger outer button selects the thousands, and if there was an action to be done here, I would press the knob and it would take it. For instance, on the Garmin G5 HSI, I can turn the knob to change the heading bug, but if I press the knob for 2 seconds, it synchronizes the heading bug. In the middle of the right-hand touch-sensitive panel, I have a perfect replica of the Garmin GTN 750 multi-purpose navigator, flight management system, and comm system. It is based on the official Garmin simulator, so it has all of the functions of the simulator. Right now it's showing us that we're parked in front of the east apron at Manassas Airport, but I can create a flight plan. For instance, let me load the approach back to the ILS approach back to Manassas, and using the manual transition, and we're loading the approach. So if we go back to the flight plan, here we have all of the elements of the flight plan. That's not what I wanted to do. Okay, there we go. And if I zoom out, you can see all the elements of the flight plan. It will also do communications. For instance, I can go and find the Manassas frequencies, and let's start with the ATIS, and let's also put ground clearance delivery on this radio. And I can also control the transponder, and the VHF navigational radio. So it is a complete model of the GTN 750. On the right-hand touch-sensitive panel, I have some simulator controls. I can pause the sim. It is paused right now. Now it starts working, and it's paused again. Touching this button will increase the ground speed or the position acceleration velocity of the simulator by a factor of 4. This button resets the sim, this quits it, and this opens up the replay control panel so I can replay a portion of the flight. Here is a display of the frames per second that the simulator is running. It always tries to run at the highest possible rate. If the rate were to fall below 24 frames per second, it would start flashing. I can, sometimes in simulators, nose wheel steering becomes too sensitive, so I have the capability of defeating nose wheel steering. I can also change by hand the rate of the simulator. Now it's at 1:1 real time, but I can change it to 2. As you can see, the fast light has lit there. Times 4, times 6, 8, 12, 16, that's the max it will go. As you go down to 1, the fast light goes off, but I can also slow it down to 0.5, 0.2, and 0.1. Here, the simulator would be running in terms of attitude and all other functions, but it will not be moving because the positional speed is set to 0. And let's say back to normal. And at the very bottom of the right-hand side touch-sensitive screen, I have some quite unique simulation control features that I believe no other simulator has. Let me unpause it. Oh wow, he's giving me the ATIS. Shut up. There we go. Now we have Manassas clearance. Hopefully nobody will ask for a clearance. I can, for instance, set the visibility by activating the visibility command and then using the knob to reduce the visibility to whatever I want. Same thing for rain, cloud cover, turbulence, altimeter setting, ground temperature, and local time. In addition, I have some pretty unique controls here. This one will bring in today's actual weather. So this is the current weather at Manassas as of the moment I touch the two unique features of my simulation that I've created myself is the ability to randomize whether the ceiling is above or below minima. The way it works is first you set the cloud basis to a number close to the minimum, the decision altitude or the minimum descent, decision height or the minimum descent altitude for the approach that you want, say, I don't know, 1,600 feet. And then if I hit this random ceiling, it will at random, with a certain probability, reduce the ceiling below the minima. And of course, so you won't cheat, it changes the cloud basis and also the cloud tops, because there's a relationship between them, to question marks. And finally, the app set button does exactly that. It takes over the airplane, wherever it is flying, takes over the airplane for 5 seconds and applies a random torques in the 3 directions, pitch, yaw, and roll. And after 5 seconds, gives the control back to the pilot, and during the recovery from the upset, statistics will show up here, showing up the altitude loss, maximum indicated airspeed, and maximum positive and negative G's experienced during the recovery from the upset. Let me now show you a typical engine start. It is not quite perfect. I have to change a little bit the electric starter speed constants, and then followed by a sample instrument approach, departing from Manassas and flying back to Manassas. Okay, doors, chocks, stay down, oxygen, fuel fibers, choke off, MOR, power lever off, condition idle, bleed closed, comfort and ECS off, circuit breakers check, alternate static down, mic selector boom, parking brake as desired. Battery on, 23.1 volts, a little bit low, but it's okay on the simulator. Annunciator panel, evaluate, burst test. Everything seems to be okay. Evaluate, generator and alternator in up, low bus volts, that's on battery. Pitot heat off, oil pressure low, fuel pressure low, vacuum low, and feathered. Test fire detection. It should light the fire light, it does. And fuel on board, 580 pounds. Ignition manual, fuel pumps on manual and annunciated, ignition on manual. And avionics and autopilot are off. So we can start the engine, clear the right, clearing the left. Let's put in the nav lights and strobe lights to indicate that the aircraft is about to start. And let's hit the starter button. We have rotation, and we have oil pressure, and 18 ng. We can add in the fuel. We got combustion, and it's a normal start. We got NG over 63%, and the prop is going to 1,200. At this point, we can put the alternator on. It will increase the voltages, and here's the alternator picking up the load. Then the generator, further voltage increase, and 28 amps pickup. Now let's set the avionics on, and we have the G5 starting, and the 750 also ready to start. Let us continue. Bleed autopilot on. Bleed air in. ECS cabin pressurization on normal. We're gonna, I think we're ready to taxi. Okay, here we are ready for takeoff at Manassas runway 34 right. The weather is 09, it's 010 true at 6. And the altimeter setting is 3023. So let me set the altimeter. 3023, quite high, huh? And did about 180 feet, which is the fuel elevation. Okay, let's see, before taking runway, toga. Take off, go around, it's this button here, and you should set the autopilot in roll pitch, it already is, but then the command bar should climb to 8 degrees. So we'll go toga, autopilot desired heading and altitude. I'm going to keep runway heading, and I have the Arsenal 5 departure program on the flight management system, and the CDI is selected GPS, magenta line. Pitch and trim indicators, takeoff pitch and rudder trim 3 degrees. Bleed is open, ECS normal, cabin pressure dump is off. Fuel pumps manual verify, ignition manual verify. Transponder, let's assume they gave me a 5351 transponder. So we got the radios on. I'm not going to worry with the comm radios. Traffic display system is enabled, and landing light is on. Runway items, runway heading, 34 right, verify, 341, close to 340. Fuel pumps and ignition on and announced. Pitot heat is on, recognition lights are on, pulse, annunciator check, and we don't have the friction, our lever friction is forward, and we're ready for takeoff. Now, as you will see, the weight on the elevator pulls the yoke forward, pitch down. But as we pick up airspeed, you will see the yoke coming back to a more neutral position. So let's release the parking brake, and here we are. At about takeoff power. And here is the yoke coming back. It's now more neutral, 65 knots, cross check, 85, rotate, pitch attitude, and gear is coming up. Hydraulic pump is on, and gear is unsafe, but now gear is safe. So here we are, going to trim the aircraft a little bit, and as soon as the aircraft is trimmed, I'm going to set the autopilot on, and the horizontal command will be navigate, and indeed we're ready to turn to the left towards the 800-foot point. And now we'll keep an indicator airspeed, 139, that's a pretty good indicator airspeed. And now I can turn the fuel pumps to auto, ignition to auto, and reduce the rudder trim, wrong direction, there we are, until the ball is a little bit more centered. Okay, we're in the soup now at about 1,400 feet. By the way, I'm flying the actual current weather at Manassas, so it's a good, will be a good instrument approach, and we're headed towards Shirley. The departure procedure has us going to Shirley at 2,000 feet. They usually give you climb via the SID except maintain 2,000, so I'm going to mimic that typical departure instructions from Manassas. However, as we go near Shirley, the controller will very likely give me a 360 heading. So to be prepared for that, since I've done this many times, in real life. I'm going to preset my heading bar to 360 in expectation of a possible, but not certain, turn right heading 360 instruction from the controller. And probably around that time he'll also clear me to high altitude, most likely 3,000 feet, because that is the initial altitude for the ILS approach. Okay, let's verify that we've done everything on the checklist. Gear up, flaps up, fuel pump auto, ignition auto, cabin altitude. It's pressurizing a little bit. I mean, we're only at 2,000 feet, but there's like 3/4 of a PSI differential. Landing light off, although it does turn itself off when the nose gear is retracted, and rudder trim center. We got it. Climb checklist complete. And here we are turning into the turn towards Casanova. So at this point the controller is going to say November 31062, fly right heading 360, climb maintain 3,000 feet. I had already selected the heading, so all I had to do is press heading mode on the autopilot. Now I'm going to set my altitude pre-select to 3,000 feet. Here we are, 3,000 feet. I'm going to go VS, maybe 800 feet per minute. Now let's go to 1,000 and add a little bit more power. And as you can see, the automatic fuel balancing has triggered because we have 283 pounds in the right tank and 265 from the left. So the right fuel, auxiliary fuel pump, will be on until the difference closes to about, I believe, 10 pounds of difference. So now we are off the navigation path. We're off the SID, climbing to 3,000 feet, 400 to go. And in order to accelerate the exercise a little bit, as soon as we get to 3,000 feet, I'm going to hit the fast button and go 4 times faster than normal. Autopilot has captured 3,000. Let's let the airspeed stabilize. Let me go to about 700 pounds of torque. At this low altitude and in the terminal environment, I probably don't want to go any faster than that. Okay, let's go fast, and until we are roughly a beam of GG. Okay, let's go back to normal speed, and at this point the controller will say November 31062, fly, turn right heading 131, maintain 3,000 until established. You're clear for the ILS 16 left approach at Manassas. And I will repeat the instructions. Go to 131 heading. I am at 3,000 feet, so I stay there. Get a little closer, and it looks like I'm going to intercept the final approach course pretty darn close to GG. So let's get ready for the approach, and for that we want first of all to make sure that we have the right frequency, 109.1, 109.1. Review the approach, 3,000 until GG. After GG, it looks like we're going to actually intercept a little bit beyond GG. So as soon as I'm established, I can descend to 2,200 in anticipation of Dorch, which is the final approach fix. At that point, I should be configured to begin the glide slope descent, and I will be following the Malibu Meridian Owners and Pilots Association standard operating practices, which is what I fly in the real airplane. So let's start slowing down to about 500 foot-pounds. Indeed, I was going kind of quite fast. And let's go to nav and approach. Indeed, we're on the, oops, no, let me go back to heading. That was not good because I want to be established on the approach. So we're going to be on the GG to Dorji leg. So I'm going to activate leg. And now I can go on nav mode. And as you can see, since I was within the right distance of the final approach fix, the 750 has automatically transitioned to V-lock. So I'm intercepting V-lock, the glide slope is coming down. So let me do the before landing checklist, which is fuel pumps manual, ignition manual, cabin altitude is the one I would expect, and landing light on when clear to land. And here is the glide slope coming down. Let me get rid of a little bit more power here. I am within the 168 knots gear and flap stand speed. So now it's captured glide slope. Gear is coming down. I watch for confirmation. 1, 2, 3, and 10 degrees of flaps. Check with the indicator. And as soon as the speed goes below 138, I'm going to put 2 notches of flaps. Even though we're following the localizer, I always like to center the heading buck. So there we go, center. Now let's review the approach. Again, the decision altitude is 392 feet, which I'm going to call 400 feet. And the missed approach is climb to 700 feet, then climbing right turn to 3,000 feet direct Casanova. At that point, if I have to do the missed approach, I will revert back to GPS, let the 750 guide me through the missed approach details. But only after I have established by hand the aircraft in the proper climb configuration and have cleaned up gear and flaps and have climb power. I have some ground contact, but nothing in the front. There we are in the clouds again. And it's uncanny to think that this is the actual weather at Manassas. If I were flying the airplane really this afternoon, I'd probably be encountering some very similar conditions to these. It would be a good day to have gone practice instrument approaches. Again, we're looking for 400 feet. And passing through 1,400, so 1,000 feet to go. Meanwhile, speed 138, probably good enough. Let me slow down a little bit more. And let me set the second notch of flaps at this point. But actually, there is a runway there.
2 mile final runway 16 left.
And we broke at about 1,250 feet. So no big deal. So let's do a final approach. Fuel pumps again, manual. Cabin altitude is depressurized and landing light is on. We are clear to land runway 16 left, Manassas. Okay, 900 feet, so 500 to go.
$500.
Thank you. And all the needles are centered. Their speed is right where I want it. Below 120 for the approach. And actually, if below 118, I can set flaps 10. We're 200 above, so I'm going to disengage autopilot at this time. The autopilot always leaves, this particular autopilot leaves it trim, nose down. So I want to make sure that I trim it nose up on gaining control. I go flaps 36. And the speed is bleeding down nicely. I'm on the glide slope, still a little bit below the glide slope, but that's fine. I'm looking for about 95 over the threshold, and there we are, 95 over the threshold, trimming up a little bit. Power off. And there we are on the distance markers. There we are. Nose wheel on the ground. reverse, brake. We're below 40, so reverse is off. And here's a high-speed turn off to my left. I would now like to demonstrate the automatic upset generation system on my simulator. For that, I'm going to stabilize the aircraft around 4,000 feet on a 270 westerly heading and about 600 foot-pounds of torque. So the aircraft is relatively trimmed, and the upset generator takes over the aircraft for about 5 seconds and produces a random disturbance in pitch, roll, and in yaw. After 5 seconds, a long beep will sound to indicate that I should take control of the airplane. I could close my eyes in those 5 seconds to simulate being surprised by the upset. But I'll just keep my eyes open. There we go. Upset on. And in 5 seconds, goes beep. All right, so I'm climbing. So I'm going to push down. I'm going to roll wings level. And I'm going to go down to 4,000 feet. So while I've been recovering from this upset, it is logging my performance. It was an upset in the up direction, so I didn't lose any altitude. The max airspeed that I got was only 166. I pulled up 1.29 Gs positive, and I went down to 0.47 Gs on the down recovery, 1 G being wing supple flight. Okay, let's try it again, see if I get another type of upset. Pushing the upset button again clears the readings. Pushing upset again it gets the airplane upset, and when it goes beep, I can look it up. Oh, I am going down pretty fast. So wings level, very important, and back to 4,000 feet. And now I can add power. The sound was the landing gear warning because I had set the engine power to idle. Okay, so now I look at the statistics from this recovery. I did lose 382 feet. By the way, the altitude loss is computed beginning at the point at which the upset system lets me control the airplane again. So it's really the altitude I lost, not the entire altitude lost during the upset. Airspeed went up to 191 knots, so slightly above 188, but at least it didn't tear the wings off. I did pull 1.77 Gs in the recovery, and I went down to 0.61 on the return. So that's how the automatic upset system works.